When I look at this problem, I see that there's an equal sign, so it's an equation, and the directions say solve. So I'm trying to find any value or values that make this equation true when substituted for the variable a. Since this is an equation, I can multiply both sides by any expression I choose. And since there are fractions involved, I'm probably going to want to multiply by the lowest common denominator, or LCD. The LCD needs to contain any factor from one of the individual denominators. When I look at the first two denominators, a minus 4 and a plus 4, since those are pluses and minuses, the a and the 4 are not factors on their own. Factors are things that are multiplied together. That means the whole quantity a minus 4 and the whole quantity a plus 4 are going to have to appear in my LCD. The third fraction has a denominator of a squared minus 16. That can actually be factored. That's the difference of two squares. So I'm going to go ahead and do that. I'm going to leave the first fraction alone. I'm going to leave the second fraction alone. But I'm going to factor the denominator in this third fraction. So the 5 stays as it is. And I'm going to get two sets of parentheses, two binomials. Difference of two squares. Remember, a squared then has to be a times a. The 16 has to be 4 times 4. And difference of squares has this pattern where one's going to be plus and one's going to be minus. So my LCD then is going to have to contain the whole a minus 4, the whole a plus 4, and then it's going to have to contain both of those factors from this right-hand fraction. But I really only have to include it once. So my LCD here is going to be the a plus 4 and the a minus 4. Notice that each of my individual denominators is part of this LCD. So I'm going to multiply both sides by this LCD. On the left-hand side, I notice that there's a plus between the two fractions. So when I multiply by those two fractions, it's going to have to get distributed to both parts. So I'm going to have to write the LCD down twice on the left-hand side, once next to each fraction. But I only have one fraction on the right, so there's no distributing to do on the right. So I'm going to go ahead and do that. So I'll take a plus 4 times a minus 4 over 1. That's going to be my LCD. Now I'm going to save that so I don't have to write it over and over again in this problem. Alright, so I'm going to multiply that by this first fraction, 3 over a minus 4, plus, let's copy that. There's my common denominator. I'm going to multiply that by 2 over a plus 4. That's my second fraction. And I'm going to do the same thing over here. So I get 5 over a plus 4 and a minus 4. Sort of long here. Barely fits. Okay, now we've got stuff canceling out. Here the a minus 4's cancel. Here the a plus 4's cancel. They're common factors. And here they both cancel. Alright, see how that works? That's why we chose the LCD. It makes everything go bye-bye. So what's left in my first fraction here? I've got an a plus 4 in the top and a 3. So that's going to be 3 times a plus 4. Plus, here I've got a 2 left and an a minus 4 left. And then on this side, I've just got a 5. Alright, so now I'm going to distribute 3a, 3 times 4 is 12. And then 2a, 2 times negative 4 is negative 8. And the 5 just stays there. I see that I probably can clean up this left-hand side. 3a plus 2a, those are like terms. I would get 5a. Positive 12 and negative 8, that leaves me with a positive 4. That's equal to 5 then. Now I'm going to solve this equation. It's just a to the first power. This is a linear equation, so I can just get a by itself. So I'm going to subtract 4. That leaves me 5a equals equals 1. Then I'm going to divide both sides by 5. So I get a equals 1/5. Since this is a rational equation, my variable appears in the denominator. I just need to make sure that this solution doesn't make any of the denominators equal to 0. It's helpful probably looking at the factored form, the second step. If I plug in 1/5 for a, I get 1/5 minus 4. That's not 0. The second fraction, I get 1/5 plus 4. That's not 0. And then the third fraction, I get 1/5 plus 4 and 1/5 minus 4. Well, whatever that is, it's not going to give me 0. So I'm pretty confident that a equals 1/5 is my solution.